today I will be giving you a short presentation about how to integrate security into your blockchain project. So to start with, we need to understand how is like a regular web project, web software is different from blockchain software, and how the process is different. Basically, both of them contain code. There is some agile process for SDLC where you have different stages for development, for testing, for going to production, and so on. Both of them need security review. There are some compliances. For example, for web it can be PCI DSS. For blockchain projects you have like cycles with implementation, design, testing, evaluation, requirement analysis, so on and so forth. After that, we are going into audit. We fix issues that were found by third-party reviews, and then we go to production. So pretty straightforward. So when we are talking about classic SDLC for web projects, these domains are applicable for blockchain development as well. And there are some that are not applicable, but if we consider the main ones, they are all the same. So for the blockchain security, we will still need to do threat assessment, we will still need to do security requirements and architecture. We need to have a developer certification, how to properly write the smart contracts. We need separate, very secure process, how to store key, like private keys, all the secrets. We also need to have like QA testing. It doesn't mean that we need QAs. It can be done by developers, but internal testing should be definitely done. Also security testing, compliance understanding, and also operational management and incident response after we go to production. So basically, also smart contracts or blockchain should be monitored. There should be incident response plans. If something was found during some reviews or some production incident, you should know what should you do. So, what should be done to be more secure if we are developing some blockchain software? I have like 4 very basic, very simple steps which should be considered if you are developing some blockchain application. So first of all, it's developer certification. Developers should study existing types of vulnerabilities and attacks. If we are talking about smart contracts, the very basic level is SWC. It's Smart Contracts Weakness Classification. It's the list of all major attacks and vulnerabilities that are already known and that can be found in the Solidity smart contracts. When you go to this registry, you could see the examples for each type of vulnerability. For example, for reentrancy, you have the description of vulnerability, and you have the pieces of code, the vulnerable piece of code, the exploit, which can be used to exploit this vulnerability, and also the fixed piece of code. So it's the example how to write the smart contract securely. And the second very important thing is that if you need to research and understand your competitors very well. So basically, if you're developing some DeFi product or NFT product, doesn't matter. You always have competitors, and they have own history. And basically, they could already have some attacks or vulnerabilities. If you're building some DeFi platform, you need to see what was exploited in like Compound, in Maker, or any other like DeFi application. You need to understand flash loans. And when developers understand all this stuff, they care about their code. The risk of making this vulnerability is like much lower. The second step is like perform architecture review and threat modeling. This is like seems pretty obvious, but it's not done by a lot of teams. Basically, threat modeling is a process by which potential threats are identified, enumerated, and the mitigations can be prioritized. What does it mean? If you're developing some, for example, NFT project, let's continue with NFTs, like all the previous speakers are talking about them, and like very hype stuff. So basically, there should be some security-specific requirements. For example, there should be requirements regarding data availability. So, for example, there should be requirements about data accessibility. If I own some NFT, no other person in this room could access my NFT, only I could be the person who transfers it. And all these requirements should be understood, and when you understand what can potentially go wrong, you could develop an architecture, and on architecture level you understand all the potential issues, and it also reduces the risk of future vulnerabilities. And also, very important thing is to start to have an architecture documentation before you actually develop in a code. Because in many cases, you need to, like in blockchain world, you're very limited on time, and you need to do it like very fast. You start coding, you have some requirements, but you don't have the final architecture before development. And when you're in such hurry, you can make a lot of different mistakes or vulnerabilities that are left in the smart contract. And when you're doing this threat modeling, you could identify risks. For example, when you're developing just some basic, very basic token, that is ERC20. If you do own research, you will know that ERC20 standard has front-running vulnerability in a proof function like built-in. And if you know this, you need to know how to mitigate this, or you accept this risk and you develop this, you just deploy this one contract without any changes, or you mitigate it by adding two functions like increase allowance and decrease allowance. The next one is to create project documentation, and you should also have specific security requirements. So there are a lot of projects that doesn't have documentation, and it's like very obviously it's bad practice. Tech documentation should contain security-specific requirements, like I've already been talking. Tech documentation should also contain access metrics for all the parts. So you should understand who are like owner, who is manager, who is like privileged user for smart contract, and what is the final access matrix for it. And also, it's very good to have visibilities and modifiers, like also predefined when you develop interfaces before you're going in and write the functions themselves.